Hi everyone, thank you for joining me. In this session, we'll have an intro to event-driven development, or in short, we can call it EDD. So hi, my name is Tal, and I've been a full-stack developer for the past 3 years. I love learning and I love creating things from scratch, and these are two of the reasons why I became a software developer. Who here has used a sign up or a login to an app? Did any of you fill a form and expected to see a success or a failure message after submission? Any in-app notifications? Whether you're a software developer or just an application user, you've encountered event-driven development in your daily routine. As the name suggests, with event-driven programming, application software is designed to react. In terms of programming, events are actions that a user performs, such as mouse click or keystroke. It can also be system generated, like program loading or messages between sensors. As soon as the user performs an action, the application detects it and deals with it using event handling procedure. These days, where every one of us uses mobile or web apps as coherent part of our life, we expect them to be fast and responsive. Derivative programming serves the user with the quickest and most accurate responses, which typically translate into better user experience for any given app or program. EDD must not be considered as programming language or technology. It is an approach that's implemented during the product development. It can be written in any language and is supported by almost all object-oriented and visual languages. I work at a company where we do projects, so I get to work with different frameworks pretty often. In the current project I'm working on, we're using a relatively new framework, and we had a problem passing information between components which aren't rendered under the same tree in the DOM. After exploring a bit, we decided to implement a PubSub mechanism. PubSub is basically an architecture where there are publishers of messages and subscribers that use those messages. Once a publisher fires a message, the subscriber will catch it, process it, and handle the information in the way it needs it. It's a specific implementation of EDD. When I needed to learn this mechanism, I deep dive into this topic and I understood that I've been using it without even knowing it. Every time I added an event listener to an HTML element, or even when I used Redux, the dispatchers. The events are dealt with by a central event queue, usually called a dispatcher or a scheduler, that runs continuously in the background and waits for an event to occur. When an event does occur, the scheduler must determine the type of the event and call the appropriate event handler to deal with it. The information passed to the event handler by the scheduler will vary, but will include sufficient information to allow it to take any action necessary. So we've mentioned dispatcher and event handler, but what are they? In an event-driven system, a number of events can occur in a relatively short time. The scheduler and the event handler may not be able to handle all of the events immediately as they occur. The obvious solution is to place unhandled events into an event queue until such time as they can be dealt with. Events are added to the end of the queue as they arrive and are dealt with by the scheduler once they reach the top of the queue. Event handlers can be seen as small blocks of procedural code that deal with a very specific occurrence. They will usually produce a visual response to inform or direct the user and will often change the system state. The state of the system encompasses both the data used by the system, like the value stored in a database field, and the state that the user interface itself. For example, which on-screen object is currently focused, or what is the background color of a text box. Within an event-driven programming environment, standard events are usually identified using the ID of the object affected by the event, meaning the name of a button or an input field in a form, and the event ID, such as left click, double click, etc. The information passed to the event handler may include additional information, such as the X and Y coordinates of the mouse pointer at the time that the event occurred. Each event could be handled by one or more handlers. They will get the same information from the event, but will use it and process it differently. Such as the cupcakes you see in this picture. They all started with the same ingredients, but were processed differently, and therefore we see different outcomes. Now we're going to see two short code examples of how EDD is implemented. Here we can see a very simple HTML. We just have a button with an ID of subscribe. Here we're creating a new JavaScript custom event called new message. It holds the detail of a message that says, thank you for subscribing. We're adding an event listener to the button that every time it's clicked will dispatch the event we just created. We have another component in our app. We're adding an event listener to it to listen to the new message event we created and handle it with the new message handler. In the new message handler, we see that we're taking the message from the event detail and write it in the inner HTML of an element that has an ID of greeting. Now we're going to see an example of Node.js. For those of you who are not familiar, Node.js is an open source, cross-platform backend JavaScript runtime environment that executes JavaScript code outside a web browser. Node.js lets developers run scripts on the server side to produce dynamic web page content before the page is sent to the user's web browser. Here we create a server listening on port 8081 localhost. On the server object, we call the on method for registering two listeners functions. The listening event fires as soon as the server starts, while the connection event fires when a client connects to the localhost. Let's review the disadvantages of it. Since events are asynchronous, there can be no anticipation of a specific order of occurrence or assured delivery of anything. Duplicates may occur in differing conditioning that may each require a contextual response. Development can be somewhat complicated due to the asynchronous nature of this pattern, as well as contract creation and the need for more advanced error handling conditions within the code for unresponsive events handler or failed brokers. Perhaps the most confounding challenge in using EDD is the difficulty in providing root cause analysis for any given failure. As the amount of event producers and event consumers increase, it becomes more and more difficult to trace back activities occurring within and between them. While individual unit testing is not overly difficult, it does require some sort of specialized testing client or testing tool to generate events. Also, when not dealt with correctly, it could be hard to identify the specific event that causes a bug or the matching event handler when a few are triggered by the same event. EDD may have a few flaws, but it definitely has a lot of important advantages. EDD system provides an extreme level of encapsulation and separation between components. The great distribution of this paradigm exists because an event can be almost anything and exist almost everywhere. The architecture is extremely loosely coupled because the event itself doesn't know about the consequences of its cause. Since event processors components are single purpose and completely decoupled from other event processors, changes are generally isolated into one or a few components and can be made quickly without impacting other components. One of the most important values of its high performance it helps achieving through its asynchronous capabilities. The ability to perform decoupled, parallel, asynchronous operation outweigh the cost of queuing and dequeuing events. When we look at the future of EDD, like Node, I've mentioned before, we're seeing increasing the use of serverless applications, which are using events as their core. More frameworks and architecture based on EDD are created, and existing ones keep on being very popular. It's not hard to see that EDD will only get an even more integral part of software development as we keep the user as a center part of our application. Thank you for listening. Please feel free to reach out and ask any questions that you might have.